Recursion is responsible for images like this. Maybe you've seen images like this. This is called a fractal. And a fractal is an image that is composed of parts that repeat themselves in smaller sizes to compose the larger picture. So the idea here is, you can see we've got a kind of a spiral shape here, and it's got a very, very specific trajectory. And if you look closely, you can see copies of that spiral shape at various sizes. And if you were to zoom way in on this, you would see them repeated at various sizes throughout that image. And a fractal is a mathematical concept by nature, but the production of fractals is often carried out by recursive programming. And so this idea, the visual of something that repeats itself over and over and over at smaller and smaller sizes, and those smaller sizes build up to create the larger shape, which is the same shape, is sort of an idea that is present in recursion. We also see this naturally occurring in nature. This is Romanesca broccoli. I've never had it, so I can't tell you how it tastes, but I think it looks amazing. And you can see these cone shapes here are repeated at smaller sizes to build up the larger one. And if you look closely, these smaller cones are made up of even smaller cones. So this is a naturally occurring thing that happens, and you can see there's a very mathematical pattern here. And so it's a very amazing plant in that it repeats itself so accurately. Now, this is a much simpler fractal, and it's a fractal because it repeats itself. And if you were to peel this apart, it's got 3 or 4 layers here. But if you follow the trunks closely, each one goes a certain distance, breaks into 4, goes a certain distance, breaks into 4, goes a certain distance, breaks into 4, until it reaches a small enough size, and then it retracts. So this is something that was created by a recursive loop. And so let's take a look at some fractals. Okay, so some fractals in Python, and a lot of these are uploaded. You can download the code and play around with it. But using Turtle, I can create what's called the dragon curve fractal, and this is a relatively famous, if there's such a thing, fractal design. And what you'll see here as this starts to draw is that it's being drawn by little tiny square segments, but it's got that very pleasing curve similar to the first fractal that I showed you. And it's made up of the same kind of smaller shapes. Now, this is a much lower resolution version of what I just showed you at the very beginning of this. And I also set it to slowly change color as it curves around, because it helps us to be able to track where it's going. But it's being drawn by basically a mathematical formula. And the code for this, let's take a look at it. Okay, so we've got a draw dragon curve function here, and it's got a number of parameters. But the main thing that I want you to notice inside this function is that it calls itself. So I've got a function that's calling itself over and over and over. Every time I'm in draw dragon curve, it calls itself. And that's how we get those shapes inside of shapes. Now, for something that seems complex, it's a relatively short piece of code. And if I go back to this, you can see here it's kind of progressing a little bit. But you can kind of see the shape that it's beginning to emerge here. And if I let this run all the way its course, I don't know, it'll probably take about 5 more minutes. But that dragon curve is kind of a cool fractal to play with. And like I said, I think I uploaded that to our Canvas code samples. So if you want to play around with that or let it run all the way, you can do that. Another fractal that you can illustrate, and this one's a little bit more mathematically advanced. It's called a Mandelbrot set. But if I run that, it looks like this. And if you Google Mandelbrot set, you'll see this is a simplified version, just drawn using dots, basically. But if we Google Mandelbrot set, D-O-B-R-O-T set image. Okay, so there's an image of the Mandelbrot set that's pretty. I may even have it on. No, I don't. Okay. So that's the Mandelbrot. And if I want to go really simple, here is a very simple tree fractal. And you can see how it's drawing it. Okay, so every branch splits into two until it reaches a certain size. But every branch calls itself a couple of times. So we draw this simple tree shape using recursion. And if we look at this, we can see here, we've got a draw branch. And you can see here, like I said, it calls itself 2 times inside that function. So it's building a function inside a function.